Alright, okay, this will be another examples of parametric differentiation. So asking you to find the dy dt, right? So dy dx. So dy dx is dy dt multiplied with dt over dx, right? So I'm going to differentiate x with respect to t. So x is t plus with 1 over 2, right? 1 over 2, the t power negative 1. So you find dx dt. Dx dt will be 1. Differentiate t is 1. Differentiate 1 over 2 t negative 1. Negative 1 over 2 t to the power negative 2, right? So you will have 1 minus 1 over 2t power of 2, right? 1 over 2 t power of 2. So I know later I need to reverse this thing, dt dx. So I think I combine the fraction first. So I will getting 2t power of 2 minus 1 over 2t squared as 1 multiply 2t squared, 2t squared. So the denominator have the same term. So then I have 2t squared minus 1, right? So then from here, I already know that I need the dt dx later, which will be 2t power of 2 divided by 2t squared minus 1, right? So for this side, dy dt, so you have y equals to t minus with 1 over 2 t power of negative 1. 1 over 2, the t power of negative 1. So dy dt is differentiate t, you're getting 1. Differentiate 1 over 2 t power of negative 1. So negative 1 bring forward, negative 1 times negative, you have positive 1 over 2, positive 1 over 2, t to the power of negative 2. So which will be 1 plus with 1 over 2t squared, right? Negative 2, so bring down t power of 2. So it's the same thing, I just combine the fraction, it's the same as this. So it will be 2t squared plus 1 over with 2t squared, right? 2t squared plus 1 over 2t squared. So this will be your dy dt. So then I can find my dy dx easily. So my dy dx is dy dt. Dy dt is 2t squared plus 1 over with 2t squared multiply with dt dx, not dx dt, but dt dx, which is 2t squared over with 2t squared minus 1, right? So as you know, these two will cancel off. So you will have dy dx to be 2t squared plus 1 over 2t squared minus 1. So this will be your dy dx, right? Okay, if you continue reading the question want you to finding something, right? They want you to find the value of dy dx. They want you to find the value of dy dx, the value of dy dx during at the point, right? At the point 3 over 2, negative 1 over 2, right? Okay, let's see how to solve this type of question, right? Let's evaluate dy dx at this point, right? At this point. So you know that you need the value of t to find the dy dx, right? This is the gradient of tangent. So your x, you have x, you have y. So I just substitute either one. I just using 3 over 2, right? X is 3 over 2. Or you may use y, right? So I'm using 3 over 2. So 3 over 2 will be equals to t plus 1 over 2t, right? So I know the value of x. I have to find the value of t in order to using the dy dx there to evaluate dy dx. So I multiply everything with 2t. Okay, I multiply with 2t both sides so that I can eliminate the denominator here. So I have 3t. Here I have 2t to the power of 2 plus with 1, right? So if I arrange this, I will getting a quadratic. Means that I have two possible solutions here. I have 2t, 1, 1, negative, negative, right? Negative t, negative 2, negative 3. So I have two solutions. T is 1 over 2 and t equals to 1, right? T, 1, 2. If you If you want to using value of y, means that you substitute x equals to y equals to negative 102 here, you are still getting the value of t, right? You are getting the value of t. Where if you're choosing x, okay, you try 1 over 2, right? 1 over 2. So 1 over 2, if you're putting here 1 over 2, 1 over 2 minus with 1 over 2 times 1 over 2. So you were still getting 1 over 2 minus 1. You're getting negative 1 over 2, which is your y, right? Which is your y. So if you're choosing t equals to 1 also, t equals to 1, 1 minus 1 over 2, 1 minus 1 over 2. If you see that, if t equals to 1, you're choosing 1 minus 1 over 2. You are getting 1 over 2, but this is negative 1 over 2. So it means that the value of t equals to 1 cannot be accepted. But the question already tell you, right, t is within 0 and 1, right? So you have to reject this thing, right? You have to reject t equals to 1. One of the reason is you putting t equals to 1, you cannot get the value of y to be negative 1 or 2. Okay? So that's the reason I should reject this. So now t equals to 1 or 2 is the value that suitable to finding the dy dx. So it means that dy dx when t equals to 1 over 2, which will be 2, 1 over 2 square plus 1 over with 2, 1 over 2 square minus 1, right? So I have to evaluate this. 2 times 1 over 2 square. So you have 1 over 2 plus 1. Here you have 1 over 4, so you have 1 over 2 minus 1. So you are getting 3 over 2 divided by 3 over 2 divided by negative 1 over 2, right? Negative 1 over 2. So finally, you have 3 over 2. If you convert this, become multiply, this one will be reversed, will become negative 2 over 1. So you are getting negative 3, right? Means that your dy dx is negative 3 at point 3 over 2, negative 1 over 2. Alright, so this is the way we evaluate, right? If given the value of x, we can find the value of t. Before we using the value of t, we check whether it fit the satisfied or not, both this to getting this point, right? So we proceed and substitute the value there to find the value of dy dx. Okay, that's all for this video.